Hi, welcome back to LeetCode. So in this video, I'm going to discuss LeetCode problem 3587, minimum adjacent swipes to alternate parity. So you are given an array names of distinct integers. Okay, so in one operation, you can swipe any two adjacent elements in the array. So an arrangement of the array is considered valid if the parity of adjacent elements alternates. That means alternate means first will be odd, even, odd, even. It is also possible that even, odd, even, odd. This is actually the parity, alternate parity. Got it? So we have to actually check that we have written the number of adjacent swipes required to transform nums into any valid arrangement. So we have to find out what is the minimum number of adjacent swipes required to convert such kind of actually the alternate parity of the input array. And if it is not possible to rearrange the nums of the input array, then we have to return -1. So first of all, let's see some example. Then it will be easy to understand when actually we will return -1 and when actually we do, how can actually find out the minimum number of swipes. Okay, suppose we actually have one odd, 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 even. Okay, so from this input array, what actually I have to do? I have to do alternate parity. So that means odd, even, odd. So the input length is also 5. Here also the input length, length is also 5. Here actually how many odd are possible? 3. How many even? 2. So that's why you can see that here also the odd is 3, 2 even is 2. Got it? So this is one possible actually answer. And now another actually I can actually do such kind of that it will start from even, odd, odd, even. It is not possible. Why? Because if it start from even, then we actually need 3 even, but actually we have only 2 even. So if I want to start with even, so even, odd, but there is still actually one odd actually left. This will be placed. This actually alternate parity? No, because there actually odd actually present consecutively. Correct? So that's why this is not a valid combination. So one thing actually I can observe that if the number of odds is greater than the even, then it can only start with odd, even, correct? This is correct. This is clear. This from this example. And also similar way, the reverse is also true, that if the even is greater than odd, then it can only start with even, odd, correct? So this thing is clear. Now these two situations are clear. Now if it is possible that we actually have even equal to odd, that means suppose odd, then 3 even. So here actually you can see that odd is present 3 times and even is also present 3 times. So is it possible to start with odd? So this will be, if I want to create a alternate parity from this input array, so this will, if I assume that this is starting with odd, so it will be odd, even, correct? So this is actually possible to generate. Now if I assume that our array is starting with even, so it will be even, odd, correct? So this is also possible, because here also you can see that odd is present 3 times, here also the even is present 3 times, here also the even is present 3 times, odd is also present 3 times. So both are actually alternate, so both are actually possible to generate. So for even, if the count of number of actually even number is present equal to the number of odd numbers, then we can actually generate both the possible, starting with odd and starting with even. So both are actually possible. So what we have to do for this situation, we have to calculate that both, right? Now when actually situation will be -1, like they mentioned that if it is not possible to generate to create any alternate parity, so then we have to return -1. So when actually -1 actually we have to return. So suppose we actually have such a way, even is 3 times and one is only one odd is present. So I have already mentioned that if even is greater than odd, so it will always start with even, correct? From the previous situation. Now if I assume that okay, start from even, so it will be even, odd, even. Then is there any odd is left? No. Now actually odd is 0. I can actually present, and also but even actually we still have some element even numbers. So we have to place that, but there is no odd numbers. Yes. So that's why this is not possible to generate. So For this situation, how many actually even is possible present? 3. How many odd? 1. So what is the difference between that? 3 minus 1, it is 2. So that's why I can actually, if a difference is at least maximum 1 between even and odd, then actually I can generate a array, alternate array, parity of alternate numbers. So if it is greater than 1, then actually I can't generate. If it is less than equal to 1, I can generate, correct? So that's why minus 1 will be when our count of the difference between the number of even and odd is greater than 1, then actually we can generate, that time actually return minus 1, correct? This is clear, 1 to minus 1. Now we know that for this situation, if the number of odd numbers is greater than the number of even numbers, then what I have to do? It will always start with O. So now after this filter that the difference is always less than equal to 1, then what is the situation it can arise? It can arise these two things. The difference will be 0. Here actually the difference between even minus odd, it will be 0 if I take the absolute difference. Similarly, for this situation, even minus odd, the difference will be equal to 1, correct? This is clear. Why? Now I have to calculate the what is the minimum number of swipes required. So this is actually only one, like if the difference is equal to 1, means even is, suppose even is greater than odd, so I can generate only one pattern that will start with even, odd, even, right? So for this situation, how can actually count that how many actually swipes required? Suppose our input array is something like this: odd, even. So ultimately, where actually I'm placing this even, it is starting with even. So that means the first even it will go to here. Next even it will go to this position. Next even it will go to this position. That means first will go to 0. Next position for even number it will be 2. Next position for even number it is actually 4. So that means it is starting with 0, 2, 4. In this actually I will start to place even numbers, correct? When our even number is greater than the odd numbers. So that means I can easily find out that how many actually swipes is required. Suppose here actually our target position is 0 and our current position here actually it is the input array. The position of the first even number is 0, 1, 2, 3, 4. So I have to swipe this, I have to actually place from index 2 to index 0. So how many actually swipes required here for this here? 2. First we can actually swipe only the adjacent numbers. So first it will go to this here, then it will go to this position, correct? This is clear. Next our position of the even, now this actually placed to the target position. Now next even number actually places 3, index is 3. What is the target place? Where to place 2. So 3 to 2. How many swipes are required? 1. Next position for even is 4. Current position. What is the target position? Also 4. 4 minus 4. The difference is 0. So that's why 0 number actually swipes required. So how many total swipes actually required? 2 for this from index 2 to 0. Next is from index 3 to 2. This actually 1 and this is for 0. Total 3 swipes are required. Why actually I am only calculating this to place the even numbers only? Because anyway odd number will be placed in the in between, correct? If I place the correctly the even numbers in the correct position, then anyway the remaining number will be placed in the correct position. The remaining numbers will be the odd numbers, correct? So that's why I only calculated that how many even numbers are required for the how many actual swipes required for the even numbers only. Already starting with even. Now suppose it's starting with odd. Suppose this is a situation odd, then even. Here actually the word the count for odd is 3. Count for even it is 2. So that means it will start with 3 odd, right? I've already mentioned that if it is the count of odd is greater than even, then it will always start with odd. So our resultant array will look like odd, even, odd, correct? Now what is the input array position? 0, 1, 2, 3, 4. Now what is the target position? This is 0, 1, 2, 3, 4. So this 0, that means this 0, this odd is going to the same place, okay? So for this the number of target position is also 0 and the current position is also 0. So that's why I need to 0 swipes. Now next for odd, this current position is 1, target position is 2. So target position is 2, and the current position is current position is 1. Correct? Current position is what? 1. So how many swipes to record? 1. Next, the current position is 2 and the target position is 4. So the number of swipes will be 4 to 1. 4 to 2. How many swipes to record? 4 minus 2. It is 2. Got it? Now how many total actually swipes to record here? 0 plus 1 plus 2. This is actually 3. Got it? How are you getting the output? Clear? So if I like usually here you can check that I have actually placed all the odd numbers in the correct position. Then the remaining number means the even numbers already actually placed in the correct position already. Like even is placed in the 1 and even is also present in the index 3. Got it? So now this is the situation to when is actually even is greater than or odd is greater than even. Now when actually even equal to odd, then actually both are actually possible. It can start with odd even, correct? It can also be possible that it can start with even odd. So I have to calculate that both the pattern. So anyway, I will call the same function that if I start with odd. So suppose we actually have o even. Okay. So I am assuming that it will start with odd. So this is odd even. So this is 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So ultimately our current position is, it is assuming that it is starting with odd. So the current position is 0. Target position is also 0. So 0 to 0. Next is the current position is 1. The target position is 2. So 1 to 2. So how many actually swipes required? 1. Next is the for odd. Next odd position is 2. For the target position is 4. So how many swipes required? 2. So total 3 actually of swipes required. Got it? For this situation. Now suppose for this pattern also, I am assuming that it is start with even. So odd, even. I am assuming that it is starting with even. So it will be even, odd. So the position is 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So the target position for even, it is starting with even. So the first even position is 3. So from 3 to 0 I have to place. So 3 swipes to record. Next is position is 4 and I have to place this in index 2. So 2 swipes to record. Next is the position is for even, next even position is 5 and I have to place with index 4. So 5 to 4. How many swipes to record? It is actually 1. So how many actually total swipes to record? 3 plus 2 plus 1, it is 6. So out of these two combination, I got actually minimum 3. Actually it is 3. If I start with odd and if it start with even, I need to 6 number of swipes. So our answer will be 3 for this combination. Got it? Minimum number of swipes. So I hope this is clear that what is actually the condition. Like if first of all I have to count that how many even are present and how many odd number is present in the input array. So if the difference of the count is between even and odd number is greater than 1, then our answer will be -1. Correct? This is for first condition. Now we have already, if I check this condition, now we know that the difference will be always less than equal to 1. Correct? Difference between the frequency of even numbers and odd numbers, it will be less than equal to 1, because otherwise it will be this condition, it will be written from here. Now if I will check that okay, even is greater than odd, then what I have to do? I have to count out how many swipes required if it start with even, because only one pattern is possible if it is even number is greater than odd number. Correct? This is such a situation, and I will check that how many count actually swipes required. Similarly, if our odd is greater than even, similarly I will check that for this pattern odd, even, how many actually swipes are required. If our even equal to odd, I will check that both the pattern. It will start with even, odd, or odd, even, and I will check that what is the minimum of this, and I will ultimately return from here. Got it? The logic actually clear. Now go to the code. So first of all, I have to filter out that how many actually odd number is present, how many even numbers. So I have taken two factors. One is to store the odd number, one is to store to the even numbers. Okay. So I am iterating the input array. If the current number is even, so I'll store it in the even vector, else it will be odd number, so I'll store it in the odd vector. Got it? If our the number of odd numbers and the number of even numbers is greater than 1, so that means this is not possible to create any alternate parity numbers array, so that's why I return from here that -1. Got it? Else it is possible, because our difference will be always less than equal to 1. So I have to check that it can start with odd or it can be start with even. So honestly it can start with odd if our odd frequency is greater than equals to the even numbers. So that's why I'll check that the odd position, it indicates what the position of the odd numbers. Or similarly for even position, this vector I'm storing the position ith index. Got it? Not the number. Why? Because here actually you can see that when I'm just counting the number of swipes required, so I am just checking only the position only, that this is okay, the current position is 0, and suppose I have to pass to target position x, how many swipes are required? X minus 0. Got it? So that's why I only need to know the position of the odd numbers or even numbers. Correct? So that's why I've stored the position only. Now if it is possible to start with odd, so honestly we can start with odd if the frequency of odd number is greater than equals to the even numbers. So I will call this check swipes. It will return us the how many swipes required to start with odd something, any number, what actually we will return. So I am returning the odd vector, so that means I am assuming that this vector will start with 0, then 2, then 4, next available position, in this way. Got it? So I am actually start with odd, so that's why I am here actually passing the odd vector. Clear? And I'm storing this into the answer variable. Similar way I will check that can I actually start with even numbers. So that's why I will check that if honestly we can start with even if the even number of actually greater than equals to the odd numbers. So that's why I'm calling the same function. I'm passing the even numbers, even vector, and ultimately whatever the minimum I return that answer. So what actually how actually we are calculating the number of swipes required. So initially we will take one count vector variable that is 0, and I am iterating the all the position of the like odd or even anything possible. So now I am iterating the each position. So what is target position? It will be I into 2. So that means suppose we actually have two numbers, odd. So suppose the position is here actually it is similar. Suppose this is the way we actually have 3 odd, so it can start with odd. Okay, so the position is 0, 1, 2, 3, 4. So that means in the odd vector we will actually have 2, 3, 4. Correct? Now in the resultant, what is the position actually? It will look like odd, even, odd, even, odd. So the target position is actually 0, 2, 4. You can see that odd is present in the index 0, next is position at the 2, next is at the index 4. So that means I is equal to start I less than equal to 3. 3 number actually present, 2, 3, 4, 3 odd actually present, I plus plus. Our current target position will be what? I into 2. That means first it will be 0, 0 into 2, it will be 0. Next it will be 1 into 2, next position is 2. Next position for the current number, it will be 2 into 2, it will be actually 4. Similar, next it will be 6, next it will be 8. Alternate 0, 2, 2, 4, 4, 6, 7, it will be the different kind of number, odd or even, anything else. And next available position will be 8. So I know the target position and I know the current position. Current position is 2. I have to target position is 0. So I have to pass 0. So how many swipes are required? 2 minus 0. So it will be 2. So that's why next is our current position is 3. What is the target position? Target position is 2. So it is actually 1. Got it? So that's why I have taken only the difference. I know the target position is, next target position is I into 2, and the current position I will get from the position of I, and I will take the absolute value, because it may be possible that I have to shift the left side also possible. I can actually, it's possible that to shift the right side also. So that's why I have to take the absolute value, and I will add this into the count variable and ultimately return the count variable. So it will actually count the how many actually swipes required. Got it? So for this approach, what is time offset? Time offset it is actually we are iterating the input array. So it will be big of n if the input array length is n. Similar way, here actually we are calculating the check swipes. So if it may possible that it will be n by 2 roughly, so we can assume that roughly that our time velocity will be big of n, correct? And space complexity, we are taking yeah, 2 vectors, so it will be again big of n, because we are storing all the numbers. Actually ultimately all the numbers, not directly, we are storing the position of all the numbers, so it will be again big of n, correct? So this is clear. If you found this video useful, please like the video, and if you not yet subscribed, please subscribe the channel. And I have shared this code in the description, you can check that also. And you have any suggestion, anything else also, you can also comment on that. Bye.